So good afternoon. As you might tell from the accent, I'm not from here. So hopefully I won't talk too fast. It's about 9:30, my normal time frame. So even though I've been here for a few days, I'm kind of in the groggy mode for this. I'm going to talk about this concept called red today. We'll get into what red means, and I want to talk about how multi-dimensional monitoring is really necessary when we look at keeping track of today's modern applications. A little bit kind of about me, shorthanded. I'm an open source geek, I'm a standards wonk, and I've been known to talk for food inside of here. I'm owned by 3 cats. I have a wife inside of here. I spent 10 years as a soccer rep. I do have yellow and red cards, so be very careful inside of that. And so fortunately in 2015, I was named as one of the top 10 pioneers in open source. I'm actually very proud of that. I started with open source before it was called open source, and it kind of continues on today. It's near and dear to my heart. To talk about red, we actually have to start by talking about observability. Observability is a hot topic these days, and basically the concept is how to understand what's going on inside of our application or inside of our system by looking at the external signals that are happening inside of here. For engineering purposes, this comes down to designing and developing the exposure, the points that our applications and our infrastructures show us to tell us what's happening inside of that environment here. It is not one-dimensional. You'll hear quite often a lot of people talk about observability as, oh, it's a metrics dashboard, or oh, it's just this, it's just an event, it's just something. That's actually not the case. Each of those pieces by themselves will only give you part of the picture that allows you to figure out what actually is going on inside of the application rather than just what's happening to a specific point in time here. It should include things like logs and monitoring and events and traces and basically everything else that you can think of. For instance, we have one customer who, for instance, tracks their Twitter feed looking for certain keywords, because they know their users are going to start reporting what's happening on their website before their own tools will start reporting what's on their website. It should include elements of metrics. It should include time, because time is very important when we look at the activities inside of here. And it's got to cross all the boundaries, the applications, the services, as well as the various disciplines, dev, DevOps, and ops. So when we start looking at observability, it crosses all those things. And honestly, anything that slows you down is bad. So observability quite often gets lumped into monitoring, and I will actually do this a little bit inside of this talk here. But it's not just monitoring, and you'll also hear it talked about as 3 pillars. Observability, believe it or not, is an attribute. It's how and what the system does for you. Monitoring is a verb, and neither of those 2 things are part of your system. For this. There aren't just these 3 pillars of logs and metrics and traces. There are lots of signals. You can have RPC charts. You can look at how the API traffic is happening inside of here. You can look at core dumps. You can look at profiling data. You can look at, heaven forbid, Twitter. All those different pieces come into play inside of here. And honestly, you're going to need signals that you have not thought of at this point in time. So your observability has to be able to merge those in at the same point in time. And your signals change constantly. They are not static. They are always dynamic and always moving. So first step, everything is an event. But if it doesn't get recorded, it doesn't exist. There's an old saying that if a tree falls in the forest, did it make any sound? Well, the problem is that since it didn't get recorded, no one knows. You can show that the tree fell. You can show what the damage aspects were, but unless you record the signal, it doesn't exist. This is quite often called high fidelity inside of an observability model here. Metrics are incredibly compact. They are very efficient, but they're probably not sufficient, and they are investmentally not complete. There's a problem with metrics. Metrics are aggregates. They're things that are put together, but you can't disaggregate a metric. So the metrics are great indicators, and people use metrics incredibly often because they are simple, they are efficient, and they are, politely phrased, pretty to look at. And the opposite side is the log world. Logs are high fidelity. Logs will tell you every piece of information you've ever wanted to know about what's going on inside of your system, but they're bulky at full capture. When you're actually trying to pull all the log data in through here, then you've also got to worry about all the different pieces inside of here. And as your complexity grows, you've actually got more and more data that's coming into it. In modern times, it's not often for us, it's not unusual for us to see 50,000 log files per second, log lines per second coming into the system. 5 terabytes from a single application space coming in on a daily basis inside of logs here. And then the new thing that everybody's talking about, distributed request tracing, is really cool. But talk about volume. The average microservice round trip that happens in an e-commerce environment built for microservices is 50 to 100 items. And so now you've got logs that are another level of complexity and another level of volume inside of here. Tracing requires instrumentation. Logs are a form of instrumentation. Metrics are a form of instrumentation. The nice thing is you're probably already doing logs and you're probably already doing metrics today. Tracing takes instrumentation. The recommendation here, very honestly, I'll jump a little bit ahead here, is if you're using third-party packages, a lot of them now have tracing built into them. And if you're in a microservices environment in Kubernetes, I suggest looking at one of the service mesh products, Envoy, Istio combination, Linkerd, Concourse, because they already build tracing in for you, and you don't have to deal with that. So, in quotes, I saw a lot of quotes in one of the talks today, so this is my proverbial quote here. You see, but you do not observe. Standard Sherlock Holmes line. If you're looking at one dimension, you're going to see part of the picture and miss everything that lives underneath. So make sure that you're looking across all of those different pieces that exist. So stepping into this other side, I want to talk a little bit about RED. And RED is pretty much a subset of Google's golden signals. And it really was part of the original SRE handbook that Google pointed out. I think it's chapter 7 inside of here. It was originally put together as a concept by Weaveworks, and it was designed for microservices. And it's made up of rate, error, and duration. And we'll talk more about each one of these things. Designed for microservices, but it turns out that it matches well to any type of system that is request-driven or request-based. It is not good for batch. It is not good for single flow. It is not good for monolithic architectures. Where you're looking at infrastructure, there's a companion product called Use, Utilization, Saturation, and Errors, or you can go to the entire golden signals environment LEST, which is latency, errors, saturation, and traffic. So there's all sorts of things inside of here. But RED has significant advantages in the modern architectures that we face today, be they microservices-based, be they services-based in general, where we have response and request items that are driven. And one of the reasons is, honestly, this is a great way to measure user happiness. So observability really comes down to, in the RED terms here, a signal-to-noise problem. And generally, you look at this, that you're going to have two ways of reducing the noise. You can either reduce the number of signals that are coming in, which will reduce your noise and give you less fidelity, or you can filter on the back end, bring the data in, filter through it, and see what's going to happen inside of that. That's also a way of reducing the noise inside of here. In a sense, this is monitoring to the Chuck Norris level, because not just monitoring, but always already being willing to kick butt and take names inside of that. So it works out that you need to be able to do two things, and that really means coming down to recognizing that a problem exists, recognition of issue, as well as recognizing what the root cause of that problem is. The nice thing is RED gives you the ability to monitor and make sure that everything's okay and healthy at the same point in time, while giving you the ability to drill into these other dimensional metric capabilities to find out what's really happening. So rate, simple concept. Think of it as bandwidth, but think of it in terms of the size and number of requests that are crossing your system or your network. This can be HTTP traffic, it could be SOAP, it could be REST, it could be API calls, it could be Kafka, it could be MQTT in an IoT environment, so traditional middleware. It is pretty much anything that uses part of the communications bandwidth. And rate was originally targeted at the amount of bandwidth in use between microservice requests. We up-level that to where it becomes the length of time between requests. So what happens as things pass off and on inside of those two pieces here. In this environment, anything where slowness at peak traffic is possible, where bad things could happen, is a prospect for dealing with rate monitoring. So as an example here, this is a standard bandwidth chart. The top one is showing two things. It's showing, I believe, the sum per second in one color, the blue line, and the green line is showing my maximum capability. And it's a very pretty concept that says, oh, look, I've got bandwidth going on. Quote John Massey, he's a pretty famous computer scientist, bandwidth costs money. And so we need to know what's going on inside of here. Why is our bandwidth growing? So we can break this down and start looking at this and drilling into the information that's hidden inside this bandwidth. And what I've done is I've looked at the first one that says, what is server-wise is using my bandwidth? I've got 23 different servers that are driving about 63 different applications across those application services in this model, across those. And so I look at this, and the two things that are coming out is that the big one is imaging. Images are big, they take a lot of bandwidth. But if you notice, if you can read it, I know it's a really small print here, Web Server 6 is actually right up there with the top of the two image servers. So that leads to an interesting question. Why is Web Server 6 so high? And so that gives you an entry point to try to figure out why Web Server 6 is using all of your bandwidth, and it really probably shouldn't be. This is actually a use case that we ran into in our production system. Web Server 6 behaves badly, and it turned out that we had a load balancer problem. The load balancer was sending things to Web 6, even though Web 6 was telling it to stop sending me stuff, I'm a little busy. And so we were getting round trip traffic that was a rejection, a send and rejection, and it was just constantly sending. So it turned out to be a load balancer problem. It wasn't a Web Server 6 problem. So this allows us to start drilling into how we can find these things. The second one is crossing over and saying, okay, where is the data coming from? So now I'm doing the exact same thing and saying, bandwidth-wise, what's driving the data across here? And I'm looking at this from a bandwidth viewpoint, and I can now see that my image and image rendering files are the biggest users of my bandwidth. Errors are pretty obvious. Things that cause incomplete, incorrect, unexpected results. There can be code failures, there can be production load failures, there can be peak load failures, there can be communications. Errors require rapid response. You can't wait around to fix something inside of here, and they tend to require you to dive deep into it and look at the fidelity. This is where you start doing dimensional dives into the depths inside of here. Quick example for this is my Nginx environment here. I've got a couple of interesting little peaks. Those peaks, I happen to know they actually are fairly normal. But I can break that down as well and start looking at the data that drove that entire metric, start looking at the different levels of metrics inside of here, and I can compare it over time to see how things have changed. The reason I say that this is expected, this is actually a standard update parameter for our system. And so we do have a tendency to see errors creep up inside of here. The error numbers themselves are actually really small. So I believe it's like we end up with somewhere in the neighborhood of about 15 out of the current transaction rate that'll be somewhere around 250 to 300,000 transactions. So the numbers are small, but it is an indicator of what's happening in the error space. Duration is all about time. It puts things in causal order for you so you know when things happened. It is the user's journey through your system. So think of it as how the request goes through the system and what order it is. It's going to tell you little things about how long things took. It'll tell you about things, what was slow. Where can I start finding out what looks like was slow inside of this? And using a similar example here, this is a multi-second peak time in an e-commerce environment. In e-commerce, 5 seconds is a lost sale. A 5-second delay will cause people to walk away. 10 seconds is somebody who will go complain to their friends about your system. So now we need to start looking at those functionalities. Without drilling into it here, I can start looking at what my distributions are. I can start looking at what's causing these things, and I can start driving in, again, into the structure to figure out why things are behaving poorly. So, why red? Well, red's easy to remember. I happen to like my red wine, so that's my image for this one. But it does some really nice things here. It reduces decision fatigue. When you're setting up monitoring in the first pass here, you quite often have this huge headache that says, what do I monitor? How do I monitor it? What do I figure out? And red actually says, start here. Start with rate, start with errors, and start with durations. And as you get used to your system, add the other pieces that you may find necessary to build this out. So it's a great way to simply start with this. If you are particularly moving from monolithic to microservices, strongly recommend setting up this standard red structure to be able to monitor what's going on inside of here. It will save you headaches long down the line. It delivers a standardization. If all pieces are using red as a structure and as a format, even if they're not necessarily using the same metrics to drive the rates, if they're not using the same areas to drive those rates, you now have the same sets of information crossing all of your systems and all of your boundaries. This includes all those wonderful little infrastructure things, such as Kubernetes is the orchestrator working right, all the way through its worker nodes, its pods, its containers, its apps, all the way into service mesh layers. All these pieces fall into this. And so you have a consistency that crosses all of the boundaries inside of here. Believe it or not, it also helps with automation of process and automation of response. Because everything is standardized into what it is, it's easy to start setting up responses that are based on standard capabilities because you know what they represent. And those pieces make it really useful because we all run into boredom if we do the same repetitive task time and time again. So set up the automation things here. And finally, I mentioned this earlier, it's a great proxy for user happiness. We actually really do want to figure out how to keep the users happy. And we can look at this and say, oh gosh, the system's running fine. But what's the journey that the system is going through? How is the user perceiving your system? Is it running a little slow? Is he running into a slow consumer problem someplace? So each of those pieces then come together and bring in this concept of red. Now, I've talked about those three things here, but red allows you to also cross the streams. So any of the indicators, a rate indicator does not mean something is wrong with your bandwidth. A rate indicator could be a slow consumer model. Something is slow. And keep in mind that rate has both the capability of being too high as well as too low. If your overall rate is too low on Black Friday in your Amazon, something's wrong. Or like it was last year in 2018 for the Amazon sales days that they do in July. In the first 30 minutes, the systems failed to keep up with this. It's a quick way of figuring out what's going on here. Errors, obvious, but errors can be caused by bandwidth limits. You're out of bandwidth, you can no longer respond. Or it can be caused by response times mismatch. Something's taking longer than I expect. We had a situation literally last week where the queuing service talking to the dispatch service, one of our dispatch servers didn't stop, it slowed down. And so it wasn't handling the throughput at the rate they were going to, and it filled its queue. And then it sent messages back to the queuing server who said, oh, somebody forgot to configure me, and it filled its queue. And then all of a sudden we had a massive set of problems because our load balancers were still trying to send something to a place that couldn't handle it. And we started dropping transactions. That showed up very quickly in this red environment because the traffic, the rate between these events dropped to nothing, even though we were seeing activity happening inside of here. Nothing was happening. Bandwidth was not being utilized inside of those pieces here. And then duration, if you don't have a response, it can be caused by an error. It could be caused by being out of bandwidth again. So there's multiple things, and each of these things cross. In general, you look at the types of alerts that happen inside of here, and there are two things. There's an anomaly alert, which has something gone out of its norm or has something exceeded the threshold that I've set for it. And then you have headache alerts. Oh, geez, what's gone wrong and how do I fix it as fast as possible? You find all of these things, but rate most often is anomaly and errors are most often headaches. So in a new world we're now running into a very services-oriented world in our own right. Microservices are sort of the first step in here, but we have functions as a service, serverless models, AWS Lambda, all coming into play here. And now our applications have a totally new challenge that Red can handle for you. And that is that the thing that makes up your running application may not always exist. It's very ephemeral. And so we need to be able to track the behavior not only in terms of what time the functions took, but over time itself. And so for instance, in this graph, using the rate error durations, I can look at this and say that my log back in over the last week looks like this, and that my error rate has a 6 average on errors being pushing records into my back end here, but that it's increased by 9% over the last 4 hours. And now I've started getting another set of information based on the same functionality that happens inside of here. When we move to serverless, and the world is definitely targeted going to serverless here, we're going to see more and more need of capabilities that look at ephemeral application space and how we measure and track that to find out what our applications are actually doing. So in this space in general, talked a little bit about this, it really comes down that observability has 2 aspects here. One is the customer's view. Is our customer happy? And they're usually happy with, my request got handled, the latency was fine, and it was successful. That's really kind of their 3 things. When we look at it from our operations, our DevOps view here, it's a very different picture. We want to know really what was each request. It's an overall picture. How is the load operating across here? And is the system responding as we expect it to? And so Red, again, gives us the same capabilities of looking not only at the user side, but also at the operations side. I ran a philosophy nonprofit for Stanford for about 6 months here, so I have to have philosophy. If you work with 2 fully tenured professors of philosophy, you will learn that the hardest thing to do is to get 2 fully tenured professors of philosophy to agree on anything, even if they agree on everything for this. So, philosophy. Instrumentation is not an answer. It'll help you find an answer. So don't think that tracing is going to solve your problem. Tracing will give you more information about how to solve your problem and where your problem exists. Metrics are powerful, but not complete here. And cardinality, high cardinality matters. As we increase our loads, we get more and more high cardinality with data that's not compressible, as well as the fact that metrics aggregate, but do not disaggregate. You can't break a metric apart and find its component pieces without being able to have other pieces other than the metric itself. Observe the work. Look at what is happening inside the system, basically from the viewpoint of what's going through a request viewpoint. Don't look at the service, but watch the service anyway. In particular, you want to watch how the work affects your service load. Again, Red is positioned specifically to help you figure out how the workload is affecting the service load for this. And the goal, honestly, I started off by talking about observability. It is a hot buzzword, but the goal is not observability. The goal is trying to reduce the mean time to recognition of a problem and the mean time to resolution of the problem. Those are the issues that we need to be able to resolve when we're going forward here. Being able to say, my system's observable does you no good if, in fact, you can't do anything with the data. So finally, observability is more than just monitoring, as he falls off the stage here. And Red is great for services request-oriented type of applications. Again, don't use it in batch loads, don't use it in your single-threaded loads. It's not going to be really useful for you for those things. But modern architectures favor services models. And so as we do this, keep in mind that Red itself interacts in unique ways. And what you may see as a rate problem can be caused by a duration problem or could be caused by an error. And I'll wrap it around inside of here. Make sure that you can drill into any of those sections that are important inside of here. And then use all of your signals. Even if it is bringing in Twitter and watching for words going, is the system working fine? make sure that you're actually using all of your signals to determine, again, the user happiness inside of this environment. And with that, I'll be around during the afternoon. Feel free to drop me a line if you've got questions. And I thank you for your time and letting me come down here and visit this lovely country.